So originally I was studying a lot about smart contracts and concurrency, but from the professor's recommendation, I've been looking more now into internet identity and especially Hyperledger Indy, with the combination, of course, with the part-time work. So I will be presenting kind of an introduction to internet identity and Hyperledger Indy. And the content is as following, where I'll first have an introduction before explaining several things and the technologies that are used. So in today, internet identity challenges, it all comes down to the word trust. Is the person you are connecting with online who they say they are, and are the claims they are making true? Because in the real world, we prove our identity through government ID or maybe driving license or bank ID. But on the internet, we use this scheme which is user IDs and passwords. And there's several problems with these user IDs and passwords. One is that there's too many of them to track. So obviously it's easy to forget. And because of that, people often use easy to remember passwords. And there's also several password recovery mechanisms. And both of these provides avenues for hackers to easily attack and compromise your account. And in the same way, the same password is often used on many sites. So if someone's able to compromise one of your account, then most often they can compromise several. This also, and because of this user IDs and password scheme, phishing is also a problem where someone, a malicious entity, tries to say that they are a website, which they are claimed to be. And so there's also some additional problems that this leads to. One is unwanted correlation. Unwanted correlation is the associating without consent information about a single identity across multiple systems. And this is done through using common identifiers we use daily, like email addresses and account name. So basically, a malicious entity can use your accounts and look through their the accounts with a similar name or the same name. And that way, slowly but gradually build up information about you. The other problem is that everything is centralized through centralized identifiers. So central authority can easily choose to take away your identifier at any time. And because it's also centralized, it has the danger of being compromised, which also leads to data breaches, where the identity-related data is a favorite target for hackers. So not only can the hackers take your user ID and passwords, but they can also steal the personal information like name and email. And this is also a very high target for hackers.
Especially, we are using Zoom these days. And I saw the news that the AI can fake your face.
Right.
It's very important to identify the person is exactly what you want to communicate.
So what is Hyperledger Indy and also now ARIS and URSA? I'm only going to talk shortly about what this is, because I'm mostly going to talk more about the technology that they use. But for a basis, the Hyperledger Indy, it's a distributed ledger, which is purpose-built for decentralized identity. And it's all about the identity on the internet and being able to prove others who you are, as well as being certain who the counterparts are. And originally, Hyperledger Indy was only one project, and it's supposed to provide tools, libraries, and reusable components for providing digital identities rooted on blockchain. But because the project got so big, it got split into Indy, ARIS, and URSA, with Indy now being responsible for the distributed ledger, which is the blockchain. And ARIS now is the agent SDK and tools, and I'll explain more later what the agent is. And URSA became the cryptographic library responsible for the zero knowledge proof, which I'll also explain shortly. So how is the internet identity with Hyperledger Indy? First and foremost, they use decentralized identifiers, or DIDs. DIDs are globally unique identifiers, which are created by their own owners. That means, of course, that it's independent of any central authorities, and you, of course, have it yourself. And each DID has associated with it one or more public keys, which is created by the DID owner, while the private keys themselves are held by the owners in their wallet. And Indy uses DIDs to establish connection between two identities so they can securely communicate. And we can see an example of a DID here to the left, and it's just like a URL. And I'll explain shortly about it. And to the right picture, we can see that Alice here creates a DID for each of her service she uses. So she has a separate DID for Bob, and she has a separate DID for the bank. And likewise, Bob has a separate DID for Alice, and the bank has a separate DID also for Alice. So this way, there's only kind of one connection between each so that they can securely communicate.
You mean, I didn't get it. So Alice can have multiple DIDs?
Yes. So everything kind of comes to the same private key, but kind of the DIDs, the public keys.
Single private key with
several public keys, right?
I see. Several public.
So that way you kind of create a secure communication only like channel, but only between you and the other person. And so the decentralized, I don't know why the picture is like this. I think it's on the computer, but the DIDs, they can be resolved just like URLs, similar to the internet, but here with something called a DID resolver, which I'll not go fully into because there's a lot of technical details. But essentially resolving a DID, it returns a DID document, which you can see an example of here. And it contains the public key and an endpoint for the entity that controls the DID. And this endpoint is used to kind of chat between the two entities. And this way you can message and ask a proof that they have the private key related to that public key. And I will talk about how they prove this later. And essentially one can think of each DID kind of similar to the user ID password we have today, but of course this is secure. And so the Indy, they use the term agent for the software that interacts with other entities via DIDs. And they use the term wallet, similar to the cryptographic wallet, which is used as a data store for the DIDs and also related information. For example, a person may have a mobile agent app, and an organization might have an enterprise agent running on a cloud server. And so all of these agents, they have their secure wallet for storing this identity data. So how does each party know who it is that created and controls the DID? And that's where verifiable credentials comes into the picture. Verifiable credentials is a trusted way to provide identity attributes about ourselves. And they are the digital equivalents of paper credentials. Paper credentials being, of course, government IDs, driving license, or school diploma, etc. But they are cryptographically processed so that when we show or prove the claims, this is done through a proof or a presentation. As you can see, there's something called presentation. They use both these terms for it. The receiver or the verifier can be certain who issued the claims, that the claims were issued to the identity presenting them, that the claims have not been tampered with, and that the claims credential has not been revoked by the issuer. And the data flow is very similar to kind of the paper credentials, except we have something called a verifiable data registry, which is what is on the blockchain. So the issuer, it issues credentials to the holder, which is the entity. And both of them kind of registers on the verifiable data registry on the blockchain. And so when you want to prove a verifier that who you are, you send a presentation or a proof to the verifier, and then the verifier can check that through that verifiable data registry, which is on the public blockchain. So that way they can kind of prove it. And further, they use selective disclosure and zero knowledge proof, so that it provides an advanced feature in proving of claims that the claims can be selectively disclosed. This is done using the zero knowledge proof, which allows a piece of information without presenting the underlying data. Zero knowledge proof is kind of considered like they call it cryptographic magic or so, which is done through the Hyperledger Ursa, which I'm not going to go into the detail because it's also a big topic. But the result of this is that a person can prove he's older than a given age, for example, without disclosing any information. And so here in the picture, we can see that the issuing authority is the British Columbia. So it's correct. We can see the picture of him. So we know it's the same person that's presenting it. But instead of showing when he's born here, which is 1989, instead it will show, for example, just a check mark to prove that, okay, he is older than, say, 18 to buy alcohol or to vote. And so the question is, what goes on the blockchain? Obviously, there's no private data on the blockchain, as the blockchain is a public blockchain. And likewise, the verifiable credentials are not stored on the blockchain. They all go in the wallet. However, there's the information necessary to use the verifiable credentials that goes on the blockchain, which is the DIDs of the issuers that allows the verifiers to find out who the issuers are. This is kind of the similar to like companies or organizations. So not the private DIDs, but instead their DID. And then they have schema, which is the entries that define the data elements or the claims, and the credential definitions, which are the entries that are created by a credential issuer with a private key for each claim. We can see both of them there in the picture. And then we have the revocation registers, which are entries that give an issuer a way to revoke issued credential in a non-correlatable way. And so essentially all of the private data is exchanged between identities directly, and all of this is stored in their secure wallets. While the data on the ledger or the blockchain is more used to prove things about that private data in the order so it can be trusted. And further, I want to talk a little bit about the Sovereign Foundation, which is a global nonprofit that they're working together with Hyperledger, and they also deployed the Hyperledger Indy code on a growing number of nodes. So they have created a running public permissioned Hyperledger Indy blockchain instance. And they created the Sovereign Network, which consists of 3 foundational components. The business, which is the Sovereign Trust Framework. They made a trust framework, which is essentially rules for interaction between the organization for handling identity, authentication, and authorization. They made a series of legal agreements signed by the Sovereign Network participants. And they made the technical, which is obviously the underlying software, which is Hyperledger Indy, which is what they're using. And all of these parts are necessary to enable a global trusted system for identity. And so what the Sovereign is trying to do is they try to solve the identity problem with a global network. And if they're able to do that, then their end result is that any users can create the IDs, and they can use those to communicate securely with others, and then also use the verifiable credentials and claims to prove things about themselves, and in that way being able to execute trusted digital transactions. So for the conclusion,
Sovereign, they already have their own blockchain network already?
Yes, using Indy. And I believe back in 2000.
So is it then we can say public? Or?
Yeah, it's supposed to be public. From what I read in 2017, it was at least deployed in 14 different countries.
14?
Yes.
14 countries. So is it that managed by IBM?
No, this is managed by the Sovereign Foundation, but they're working together with IBM.
I see. Where is it located? Is it US?
I don't know fully, unfortunately. I can check it out.
Okay.
So in conclusion, Hyperledger Indy, ARIS, and URSA, they aim to solve the problem with today's internet identity. And the DID addresses the problem, which I introduced in the beginning with the identifiers, that the agent and the wallets kind of act like password manager. So it's easy for users to manage their accesses because you only have, often this is done through like biometrics for the access. And users define their own DIDs and give their DID to services to use to identify. So it solves the problem of centralized identifiers. And since users use a different DID for each service, the identity cannot be correlated. So this solves the problem with unwanted correlation. And the service gives the user a DID for the service as well. So a user can be certain they're talking to the service which they claim they are. So this also solves the problem of the phishing. And the verifiable credential, they extend the capabilities of the DIDs where that personal information and identifiers, they can be trusted, perhaps even more than paper documents, as paper documents are easily forged through, for example, Photoshop. And personal data is held by its owner, so it reduced the target for data breaches compared to a central authority. And the proofs extend the paper documents capability with selective disclosure and zero knowledge proof. In that way, they can give just information necessary, but still hold their privacy when it comes to other parts. And the Sovereign Foundation, they use the Hyperledger Indy in hope of making a global network for digital identities, kind of replacing the user ID and password scheme we know today. And so my third plan is obviously continue studying about the ID and verifiable credentials. There's a lot of technical details I have to go into. And there's also several things like the revocation part and the resolving part, because it's a very, very big topic. And then I have to try and search for problems related to those technologies. And as of now, I'm unsure about my further research when it comes to concurrent smart contract, as you recommended me to more look into this.
Okay, we'll see.
And this is the references.
Okay, so next time, so are you gonna present kind of step-by-step the installations and those?
Oh yeah, in the work. Do you want me to?
Here?
Oh, you want me to do here?
No, yeah.
I can do, but I'm still working on it because I reached some kind of problems with it. So
maybe that part, maybe
for the work,
individual, if someone interested
yeah,
in the installation.
Because I'm still kind of trying to make it because I encountered some problems. So I kind of want to talk with other developers, because most of the documentation here, there was no documentation. So I'm trying to kind of step by step recreate the demo. But the problem is it's kind of difficult because it's a new framework I never used, and it's also a new coding language.
But so, you know, if that is not working well, then how come Sovereign kind of claim that they're gonna provide?
Probably they are working together with the people that knows the code, right? So that way, obviously the one who made the code, they can deploy it. But for me, when there is
you don't have any.
I don't have any documentation or whatnot, so it's difficult for me to use it.
Or maybe you can ask in like a Google or even Neighbor.
Yeah, I've been trying.
There must be somebody who already know that kind of problem that we can approach to.
I've been trying to search, but most of them is from before it split into arias. So it's mostly beforehand, when the Indy was just Indy. So there's not that much information about the new with the arias.
But there must be some kind of group discussion site that discuss about those issues.
Maybe I will.
Usually, maybe you can try to find out. I mean,
from what I see in Hyperledger, they have kind of like a weekly meeting, but it's more about how they want to develop it further. So they gather like on Zoom, I think, and discuss how to develop it further for whoever wants, because it's all is open source, right? So, but it's more just for how to develop this further in coding and not actually learn how to use this and deploy this.
Okay, yeah, we'll see. Also, maybe you can try to find out, maybe Jungwon can help you. If there's any seminar or tutorials in Seoul, then maybe you can attend us through the Zoom. You can kind of figure out the real engineers working on these problems. Then maybe you can easily resolve. Okay.
Yep, in this one. Which one?
First of all, what's the difference between India and Fabric?
Sorry? Fabric? Yeah, because Indy, they try to be more only about the trust, and so they use it's a permission but public blockchain. It's the first. So it's supposed to be public, but only, of course, people that are verified can edit or modify it. And they use what they call a plenum, which is their consensus algorithm, which they use, I think, redundant PBFT, but they kind of did some implementation of it.
Yeah, my problem is they say public blockchain, but when you read the documentation or you go inside the code, you find it's centralization. There is the fabric. There is no special like master node or some CA have the authority to do anything with the. But in Indy, they all share the information, but they have no control. So there is one master node, there is one centralization system that control all this one. So in the end of the day, it's not public blockchain.
But it's public where everyone can use it to verify, in that sense. But obviously, changing any of the information, you have to be verified.
But verifying what, for example, in Bitcoin, they can verify transaction. But here in Hyper,
it's to verify that you are who you claim you are as a person. When you show it to someone else, you claim that
you are malicious.
Yeah.
How can they know they are not?
No, because like say if you want to go into, say you want to go on Vault, right? Then you have made your own DID, but everything here is like on the phone, right? So you can show this. And as I explained earlier with the CKP, they only show the age, or they don't show the age, but they show that you're over 18, whatnot. But obviously you can just fake that easily, right? On the phone. So that's why the verifiers, they can check that with the blockchain.
But in the blockchain, in the public blockchain, there's my information, like history.
No, there's no, as I said, there's no information. It's all cryptographically made. I didn't go into the technical details, but essentially they check out your kind of public key and see that, okay, this public key is related to that private key through some kind of proof.
I think, I don't know if I'm wrong or right, I don't know, but I think there is one centralization system that gives them the information is with all of us. I have information the same, but I can't say that this node is malicious or it's trustworthy. I can't say validate this transaction. I can't say anything. It's just the master node, they check with us. Do you know for example, this IP, this ID for node, or this private key, or this public key, and that's it. We said yes, no, yes, no. So in the end of the day, there is one control, there is one system that controls all. And this is the issue with the Hyperledger as well, not only Indy. This is my thinking, I don't know. Anyway, we can chat about it.
Yeah, maybe you need to
Thank you.
figure it out, whether you're right or, yeah. But if it works that way, then that's not really distributed or decentralized.
I mean, it's distributed, but there's no control. Like I cannot do. Like in Bitcoin, there is mining, and there is so many nodes. They can validate the transaction. But here they cannot do that because there is no mining.
Right.
So there is no hash. That's why they use.
I mean, Hyperledger itself is not really decentralized one.
Yeah, but they say it in the website, I think, of documentation, right? We are changing the Hyperledger fabric to Indy, which the difference between Indy and fabric, this one is more private, more centralized, but this one is distributed. I think.
That's what you think.
Yeah, I think from my view. Not make sense.
I haven't looked that much into how the consensus protocol, of course, works, but yeah.
Yeah, maybe we need to figure it out. Okay, good.
여기까지만 하고 점심